Advanced Algebra 2, Concept 10, solve quadratics by factoring. And we're going to look at, this is level 2 factoring and also some modeling quadratics in real life. So with these first examples, these are some more extra practice. So get to where you were doing your extra practice and let's try these numbers. The numbering's off a little bit. I think we jumped in our numbers. Now we're at number 19. But with factoring and solving, just the more practice you do, the better. So this first one, 5x squared minus 22x plus 8. So two numbers that multiply to give us a times c, which is 40, and combine to give us our b value, which is negative 22. So if you take a minute and think of factors of 40, so 1 and 40, 2 and 20, right? So 2 and 20, if we make them both negative, then our signs will work out. Notice our a value is 5. It is not 1, so we need to do the level 2 factoring, which is the factor by grouping. So we're going to bring down the 5x squared. We're going to rewrite the negative 22x using 20 and 2. And then we're going to group the first two terms together and the last two. When we factor out a greatest common factor from our first two terms, it's 5x, and we're left with x minus 4. We can factor out a negative 2 from our second set, and that leaves us with an x minus 4. Now our common expression is x minus 4, which comes to the front, and we're left with 5x minus 2. So we set those each equal to 0, and x will equal 4, and then we add the 2 and divide by 5, so x will equal 2/5. Always be on the lookout for a greatest common factor, and so on number 20, notice that you can factor out a 2. Then we're left with a level 1 factoring problem. So x squared minus 7x plus 12. Two numbers that multiply to give you 12 and will combine to give you negative 7. So think of the factors of 12. 1 and 12, 2 and 6, 3 and 4. There we go. And if we make them both negative, our signs will work out. Since it's level 1, we get to go right to our 2 parentheses. So it is 2 times x minus 3 times x minus 4. Now we need to go ahead and solve, so we divide the 2 away, set those each equal to 0, so x will equal positive 3 and positive 4. Now number 21, we have variables other than x and y, and we're not going to solve, we're just going to factor what we can. So notice we can factor out a 4 and an x, and we're left with x squared minus 3y. That's all we can do. Now, number 22, we are not going to solve, so we're going to ignore the equal 0. Notice that we have a difference of squares, an x that's being squared and a y that is squared. So you can rewrite that as x plus y times x minus y. All right, now let's look at some solving real-life problems. So to find maximum value or minimum value of a quadratic function, you can use factoring to write it into intercept form, and then you can find the vertex. Remember that the vertex from intercept form is p plus q over 2. The maximum or the minimum value occurs at the average of those zeros. We find the middle. We also have the other forms at our disposal as well, like standard form. So example 4, a monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each $1 increase, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? What is the maximum annual revenue? So we want to know how many bump ups in price, how many price increases should that magazine charge. So that's our unknown. Let's set x equal the number of price increases. Now we can set this up as a quadratic, but a little different than what you might imagine. I'm going to open 2 sets of parentheses. Now I'm going to put my values in. So notice that the first set of information was that when the subscription was $20, we had 48,000 subscribers. And then with each $1 increase, we lost 2,000 subscribers, so 2,000 per increase. Now we have an expression on the left which reflects the price of the magazine, and an expression on the right, which reflects the number of subscribers. And if we multiply those two together, we will get the money coming in, the revenue. So we can set that equal to capital R for revenue. How much should the magazine charge? So we need to solve for X. All right, we need to find X when R is, and we need to find X for the maximum annual revenue. So first of all, we're just going to FOIL that out, and we're going to put it in standard form. So we'll combine our middle terms. Now we need to know how much the magazine should charge to maximize the revenue. So let's find the vertex. We're in standard form. Let's do the opposite of B divided by 2 times A. So negative 8,000 divided by negative 4,000 will leave us with 2. So that means 2 price increases, 2 bump ups of $1 each. So that would give us 20 plus 2, or the magazine should charge $22 to maximize the money coming in. What is that maximum of the money coming in? Well, we can just plug in 22 in for our X value. I'm sorry, not 22, 2. That's our number of price increases. And so if we do that, then the revenue will be $968,000. Now, when an object is dropped, its height, h in feet above the ground, t seconds, can be modeled by the function height equals negative 16 t seconds squared plus h sub 0. H sub 0 is the initial height in feet of the object. So the graph of h equals negative 16 t squared plus 200, which represents the height of the object dropped from its initial height, is shown there at the left on your screen. So that model, that equation, assumes that the force of air resistance of the object is negligible. Also, this equation applies only to objects dropped on Earth, because this is the model's R gravity. For planets with stronger, weaker gravitational forces, different equations are used. So for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Have you ever done that? I've always wanted to try to do that. So let's write a function that gives the height in feet, h, of the container after so many seconds. All we have to do is just plug in 50 for that initial height in the equation that we were given. H of t equals negative 16 t squared plus 50. Now let's find and interpret h of 1, so that means the height after 1 second, and then h of 1.5 and the difference. So the height at 1 second Oh, and I'm sorry, I missed the question, how long does it take for the container to hit the ground? Let's do that first. So that means the height above the ground will be 0. So you're going to replace h of t with 0. Now we can just solve using square roots. So we'll add our 16t squared over, isolate our t squared, and then just take the square root of both sides. Since we're in a real life situation, we want to know actual estimated numbers. So we're going to write 50 divided by 16 in its decimal form, and then we're going to estimate that the time would be, the square root of 3.125 is about 1.8 seconds. So not long to reach the ground from 50 feet. Now let's interpret that h of 1 minus h of 1.5. So the height after 1 second, if you plug that in, is 34 feet. And the height after a second and a half, so I'm not showing the work, I'm just plugging it into the equation, is 14 feet. Now what does this mean? So the difference is 20 feet. So that means in half a second, that egg fell 20 feet. So that egg is falling 40 feet per second. And we show that we put a negative in front because that means it's falling. All right, that concludes all our notes for Concept 10, including this real-life application.